Alright, today we're going to take a look at just the odds for the Unit 11 section of your Semester 2 exam. This should be the most recent section for you guys, so hopefully we shouldn't have too many questions. Like I said, we are just going to go through the odds in this video, and then there'll be a second video to go through the evens. So if we take a look at number 1, you're going to tell whether the ordered pair is a solution in the linear system. So what we need to do is remember that this is our x and our y. We need to plug it back into both equations to see if it is a solution. So if we take our first equation, we have 9 times negative 3 plus 7 times 5 equals 8. So 9 times negative 3 is negative 27 plus 35 gives me a positive 8, so that one does work. In my second equation, I have 8 times negative 3 plus, oh, sorry, that should be minus 9 times 5 equals a negative 69. So I have negative 24 minus 45, which gives me a 69, negative 69. So yes, this is a solution. It does work in both equations. Jumping down to our next section here, we are going to solve the linear systems. Now if we take a look at both of these are in standard form. So elimination would be the easiest method here. Remember, we have to have one positive and one negative coefficient, and they need to match. So all I'm going to do here is multiply this top equation by negative 1. So I have negative 3x minus y equals a positive 4. Remember, that needs to get distributed to each term here. Then my second equation is going to stay the same. 2x plus y equals 0. So now I'm going to add these together so that I can eliminate my y's. They cancel out, and I'm left with negative 1x equals 4. Divide both sides by a negative 1, and I have x is equal to a negative 4. Now I need to plug this back into one of my original equations to find the value for y. So if I plug that back into, I'm just going to plug it into my second one. I have 2 times negative 4 plus y equals 0. So 2 times negative 4 is a negative 8 plus y equals 0. So I'm going to add 8 to both sides. And I have y is equal to 8. So now my solution is negative 4, positive 8. Remember, they should be written as ordered pairs. Alright, let's jump down to number 5. Again, we're going to use elimination. What I'm going to do here is, remember, we should be looking at the coefficients. So I'm going to eliminate my x's so that I only have to multiply one time. So I'm going to multiply this bottom equation by negative 2. So my top one stays the same. So I have 4x plus 3y equals 15. Then I have a negative 4x plus 10y equals negative 2 for that second equation. Now when I add these together, my x's cancel out, and I'm left with 13y equals 13. Divide both sides by 13, and I have y is equal to 1. Now I need to plug that back into one of my equations to find my value for x. So I'm going to plug it into the first one. So I have 4x plus 3 times 1 equals 15. So 3 times 1 is 3. So to get rid of it, I need to subtract 3 from both sides. So I have 4x equals 12. Divide both sides by 4, and I have x is equal to 3. So again, I have an x and a y. So my answer here will be 3, 1. Now if we move on to number 7, these ones are the most difficult type of elimination, only because we have to multiply both equations by something to find a common term. I am going to eliminate my y's, so I am going to multiply my top equation by a negative 2 and my bottom equation by a positive 3. In the end, both of the coefficients will be 6 and negative 6. So my top equation will be negative 8x plus 6y equals negative 16. My bottom equation will be 15x minus 6y equals negative 33. At this point, I'm going to add them together, so my y's cancel out. Negative 8 plus 15 gives me a 7x. And then I have negative 16 plus a negative 33 gives me a negative 49. Divide both sides by 7 here, and I get x is equal to negative 7. Now I need to plug that back in to one of my equations. I'm going to plug it back into the first one here. So I have 4 times negative 7 minus 3y equals 8. So I have negative 28 minus 3y equals 8. Add 28 to both sides. And I have negative 3y equals 36. Divide both sides by a negative 3. And I have y equals negative 12. So again, my solution is my x and then my y. So I should have negative 7, 12. Okay, let's flip the page and we're going to continue with the odds here. If you take a look at the next example at the top of the page, we are going to solve using substitution now. So this is where I'm going to find, of these equations, which one has the variable by itself. That's going to be my second equation. And I have x is equal to y minus 3, which means I'm going to plug that in wherever I see the x. So I have 4 times y minus 3 plus 3y equals negative 5. So remember, I need to distribute to each. So I have 4y minus 12 plus 3y equals negative 5. Combine like terms, so I have 7y minus 12 equals negative 5. Add 12 to both sides. So I have 7y equals 7. Divide both sides by 7. And I have that y is equal to 1. Now, when I go back, I just need to plug this back into one of the equations to find x. So if I look at this second equation here and I plug in, I have x equals 1 minus 3. So x is going to be equal to a negative 2. So my ordered pair here will be negative 2, comma 1 for my answer. All right, jumping down to our next section, we are going to solve by graphing. So remember, the easiest thing to do is list out your m and your b. So in this first equation, my slope is 1 over 1. And my b, or my y-intercept, is going to be at 0, negative 3. So I'm going to start there. Remember, you begin at 0, negative 3. And then I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. So my graph should look something like this. I'm going to try and draw this as straight as I possibly can. Then my second equation, change colors here. My slope is going to be negative 1 over 1. And my b, or my y-intercept, will be at 0, 2. So I'm going to start at 0, 2. And I'm going to go down 1, over 1. Down 1, over 1. Down 1, over 1. So because my lines aren't exactly straight, the intersection's a little bit difficult to see, but this should be happening at 2.5, comma, negative 0.5. Now remember, you can check these in your calculator using that calculate option, so you can do that as well if this one's a little bit more difficult to check. All right, let's jump down to our word problem then. So it says that you are selling tickets for a high school basketball game. Student tickets cost $3 and general admission costs $5. We sell a total of 350 tickets and collect $1,450. How many of each type of ticket did we sell? So first thing we need to do is identify our variables. So X is going to be my student tickets. And Y is going to be my general admission. Now, we're looking at two different things here. We're looking at price and we're looking at the total tickets. So to set up our first equation, it's going to be $3 per student ticket plus $5 per general admission ticket, and that's going to be equal to our $1,450. Now, my second equation, we sell 350 tickets total. So just a combination of the student tickets and the general admission tickets are going to be equal to 350. Now, if I look at these, they are set up in standard form. So I am going to use elimination. So I'm going to multiply this bottom equation by -3 so I can get rid of my X values. So I have 3X plus 5Y equals 1,450. My second equation is going to be -3X minus 3Y equals -1,050. So now I'm going to add these together. These cancel out, and I have 2Y equals 400. Divide both sides by 2, and I have Y equals 200. So this is going to be 200 general admission tickets. Now I need to find the student ticket. So I can take that 200 and plug it back into the second equation. So X plus 200, equals 350. Subtract 200 from both sides. So X is going to be equal to 150. So then it's going to be 150 student tickets. So again, there are your solutions for the odds to Unit 11. Again, this is the most recent unit, so we shouldn't have too many questions, but again, the solutions for the odds are there for you.